Hey, so we're continuing our discussion in section 6.2, and we just talked about one-to-one functions. Now we're going to move into inverse functions. Inverse functions and one-to-one functions are highly related to one another. And you'll see that fleshed out in this lecture video. So first off, we say that let's start with let f. Let f of x be a function. F of x has an inverse function f inverse of x if f inverse composed f of x equals x, and also that f composed f inverse of x equals x. So essentially what this says is when we're composing our functions, if we start with a value x, we can hit it with f and we get f of x out. Then there's another function that lets us essentially work backwards. So we have an output f of x. We can figure out what x is through this inverse function, f inverse. And hopefully you're making a connection that since we're trying to figure out what x is, one-to-one functions are going to be really helpful here, because one-to-one functions were all about being able to determine what x is. And actually this turns out to be a fact. If f of x is one-to-one, then f of x has an inverse function. The only tricky thing with inverse functions is making sure that your domain is correct. So let's go through a quick example. Let's say we have f of x equals the square root of x. Now, we know that the domain of f is, we can't plug any negative numbers into this, so it's only positive numbers. We also know that the range of f is also all the positive and numbers and 0. This will be important soon. Okay, so maybe pause the video and think about what the inverse function for f of x should be. Like if we square rooted x, how are we going to undo that square root? Okay, so hopefully you came to the conclusion that our inverse function should be f inverse of x equals x squared. After all, what we have is that if we compose these two functions, f inverse composed f of x equals f inverse of the square root of x, which equals the square root of x squared, which is x. So it seems to satisfy our definition. The only tricky thing is we need to be careful about what the domain of f is in this case. So usually, well, sorry, not domain of f, domain of f, inverse. Right, typically we would have that the domain of x squared is all real numbers. So, is it all real numbers? In this case, it turns out no. This is called, we'll have to restrict the domain so that way we have a proper inverse function. And the reason why is this condition up here, where it wants to be composed in that way. If we have f composed f inverse of x, well, that's the same as f of x squared, which is the square root of x squared, or the absolute value of x. And so what we got back was the absolute value of x, where we were really supposed to get x back. So we can't have that. There is a workaround. All we do is just limit the domain. So now we have to be careful when we specify the domain, but we just say f inverse is the function whose domain is 0 to infinity, and it can take on real numbers, and f inverse of x equals x squared. So now we've rooted out the possibility of f inverse being allowed to have negatives plugged into it, which actually solves our problem. So it seems like a bit of a technicality, and that's true, but it's just so that way we can be consistent. So we just have to be careful with what the domain is. All right. It's also, and now let's discuss an algorithm to actually, not an algorithm, but a way to actually find the inverse function. So, how do we find such inverse functions? So, one, you're handed a function. Let's say in this case you get handed, let's give it a name too. You get handed f of x equals x cubed plus 1. Now, there's a good chance that I am going to ask you to invert something like this on a midterm, so pay attention. Also, you might have to graph something like this and check that it passes the horizontal line test. So again, watch out for that. So we have f of x equals x cubed plus 1. The first one is to check that it's 1 to 1. By checking that it's 1 to 1, we know that it will have an inverse. It's kind of silly to be handed a function, someone asks if you can take an inverse, and you just start trying rather than checking if it's even possible. So we should check that it's possible first before attempting it. But we should also all know how to graph x cubed plus 1, so I'll let you guys worry about that and worry about checking if it's 1 to 1. This is a pretty easy one to see that it passes the horizontal line test. 2, we're going to notice that we're trying to solve the equation f composed f inverse of x equals x. So we're looking for something, we're looking for this function, this f inverse. And we know that when we plug it into f, we should get x back. So what we'll do is rename f inverse of x. We'll just call it y for right now. And so we'll find y where f of y equals x. So all we have to do is just plug that in. So we know that y cubed plus 1 equals x. And then we solve for y. That's pretty quick with this one. Some of them will be more challenging, but this one is fast. We just subtract 1 to the other side, and then we cube root both sides. So y equals the cubed root of x minus 1. And up here, we knew that y was equal to f inverse of x. So we have f inverse of x equals the cubed root of x minus 1. And for our last step, 3, check. Or check our answer. You know, like, you just did all this work in 2. It's possible you made an error, but it's really easy to check that you have the right solution or that you possibly have the wrong solution. All you have to do is compute f inverse of f of x and see if it equals x. And I'm going to work in a disorderly fashion by working above. F inverse of f of x equals f inverse of f of x is x cubed plus 1, which is the cubed root of x cubed plus 1 minus 1, which is the cubed root of x cubed, which is x. So there we have it. We found the inverse function, and we checked it to make sure that it actually was the inverse function. All right, in the following videos, we'll discuss how to graph inverse functions if we know the graph of the function itself. All right, see you later.